So, good day, sir. I am here today to explain and present my solution for the quiz number 1, the Carnot power cycle. The working substance for a Carnot cycle is 8 pounds of air. The volume at the beginning of isothermal expansion is 9 cubic feet and the pressure is 300 psia. The ratio of expansion during the addition of heat is 2 and the temperature of the cold body is 90 degrees Fahrenheit. So find QA, QG, V3, P3, V4, P4 pressure mean, the ratio of expansion during the isentropic process, and the overall ratio of compression. So let's go to my solution. So the given for the number 1 are mass is equal to 8 pound, V1 is equal to 9 cubic feet, P1 is equal to 300 psia, and T3 is equal to 90 degrees Fahrenheit or the 550 Rankine, and RE or the ratio of expansion is equal to 2, and also the V2 over V1 is equal to 2 and the V3 over V4 is equal to 2. So let's go for the solution. So I have here the TS diagram, which indicate that state 1 to state 2 temperature is constant, state 2 to state 3 entropy is constant, state 3 to state 4 temperature is constant, state 4 to state 1 entropy is constant. So we have a given here with T3, so that automatically it would be equal to T4 since state 3 to state 4 the temperature is constant. Now for the letter A, let's find the QA. So from the formula, QA is equal to P1 V1 ln of V2 over V1. So we can solve here our QA because we have the value of our P1, V1 and the V2 over V1. So substituting the values, so 300 pounds times 9 cubic feet times ln of 2. So we multiplied 144 inch in order to cancel the inch and replace it with the feet. And all over 778 foot-pound over BTU, so that our unit for the final answer of the QA is BTU. So QA now is equal to 346.4 BTU or 346 BTU. Next, for the letter B, from the formula of QR is equal to MRT3 ln of V3 over V4. So substituting the given values of the mass, which is 8 pound, the R, it is a gas constant of the air, it would be equal to 53.34 foot-pound over pound mass Rankine, multiplied by our T3, which has the value of 550 Rankine, multiplied by the ln of V3 over V4, which is ln of 2. So here we should have here a 550 Rankine all over 778. So the answer would be negative 209.0988 BTU. And next, for the letter C. So here, using the formula of QR is equal to P3 over V3 ln of 1 over RE. So we are finding the V3. So we can't solve this letter C for now because we don't have the value of our P3. We only have our 1 over RE and QR. So let's find first the P3, which is in letter D. So from the formula of P3 is equal to P1 over RE times RK raised to K. So our value of P3 now is substituting the value, which is 300 pound inch squared over 2 times 3.53 raised to 1.4. So in order this to know the value of this RK, since we don't have the value of the RK, only the RE. So first, let's solve for the value of RK. So from the formula of T1 minus T3 over T1 is equal to 1 minus 1 over RK raised to K minus 1. So we have the value of T1, T3, our K, and our K. Since it is air, it is automatically considered that the value of the K is 1.4. So substituting the values. So now we have the value of RK, which is 3.53. And also here, using the formula of QA is equal to MRT1 ln of V2 over V1. Since we don't have a T1 in the given values, so let's solve it for using the formula of QA is equal to MRT1 ln of V2 over V1s. So our substituting the value, so the value of our T1 now is 911.1482 Rankine. So solving for the RK, substituting the value of T1, T3, and the K, which is 1.4 for air, and calculating it, it would be equal to RK is equal to 3.53. So now since we have the value of RK, we can now solve for the P3. So P3 is equal to 300 pound inch squared over 2 times the value of RK is 3.53 raised to K, which is the 1.4. So P3 is equal to 25.65 pound inch square or 25.65 PSIA. So now since we have now the value of P3, let's proceed to the letter C, which is QR is equal to P3 times V3 ln of 1 over RE. Since we have a value of QR, P3, and RE, we can now solve for the V3. So substituting the values of QR, P3, and RE, and divide it by 778 foot-pound over BTU, so that the BTU will cancel and the unit of the answer will be cubic feet. So V3 is equal to 63.5413 cubic feet. Now let's proceed to letter E. So from the formula of T1 over T4 is equal to V4 over V1 raised to K minus 1. So we can solve this letter E because we have the value of T4 and T1 and V1 and the K. So substituting all the given values, and the answer for the V4 is 31.7915 cubic feet. And now let's proceed for the letter F. With the formula of T1 over T4 is equal to P1 over P4 raised to K minus 1 over K. So since P4, we are going to find P4, so it means that in this problem, it is in the state 4, which is the T3 and T4 is the same. So T1 over T4, 901.15R over 550R is equal to P1, which is 300 pound inch squared over P4 raised to 1.4 minus 1 over 1.4, and calculating it through shift solve in calculator, it will be given as a value of P4, which is 51.2659 pound inch squared or 51.27 PSIA. So now let's go for the letter G, which is we are going to find for the pressure mean. So we have here the formula, which is P1 multiplied by ln RE plus RK raised to 1 minus K ln of 1 over RE all over RE times RK minus 1. So since we have the value of P1, RE, and RK and K, we can now solve this problem. So substituting the given values, so our pressure mean is equal to 13.5954 psia or pound inch squared. So now let's solve for the RE, or the ratio expansion in isentropic process, which is RE is equal to V4 over V1. So the value of our V4 is 31.79 cubic feet, all over the value of V1 is 9 cubic feet. So RE is equal to 3.53. And lastly, for the question number 1, we are going to find the overall ratio. So the formula for overall ratio is RK multiplied by the ratio of expansion. So 3.53 multiplied by 2, our RO now is equal to 7.06. So we already solved all the problem in the question number 1. So let's proceed to question number 2. So question number 2. Gaseous nitrogen actuates a Carnot power cycle in which the respective volumes at the four corners of the cycle starting at the beginning of the isothermal expansion are V1 is equal to 10.10 liter, V2 is equal to 14.53 liter, and V3 is equal to 226.54 liter, and V4 is equal to 157.73 liter. The cycle receives 21.1 kilojoule of heat. So let's determine the work and the mean effective pressure. So let's go to my solution. So for the given in number 2, we have here the V1, V2, V3, V4, and the QA or heat added, which is 21.1 kilojoule. So here in our PV diagram, from state 1 to state 2, temperature is constant. State 2 to state 3, entropy is constant. State 3 to state 4, temperature is constant. State 4 to state 1, entropy is constant. So the required here is the work and the mean effective pressure. So as we all know that efficiency is equal to work net over QA. And also efficiency has the formula of 1 minus 1 over V4 over V1 raised to K minus 1. So we can use this formula of efficiency because we have a value here of V4 and V1. So this V4 over V1, it is also equal to RE. So now let's substitute the value. So the value of V4, the V1, and the K. Since it is nitrogen, the properties of nitrogen of its K is close to the air. So it is equivalent to 1.399. So solving for the work net, so efficiency is equal to work net over QA. So using the shift solve in calculator, our work net now is equal to 14.0524 kilojoule. Now let's go for the mean effective pressure. So from the formula of mean effective pressure is equal to work net over the volume displacement. So we can solve this using this formula because we have here our volume. So as we all know that volume displacement is equal to higher volume minus the lower volume. So here, as you can see in our PV diagram, the volume here in state 1 is from state 1, and the highest volume is in the state 3. Lowest is the state 1, the highest is the state 3 in terms of volume. So volume displacement is equal to V3 minus V1. So work net all over the volume of displacements, which is the V3 minus V1, substituting the value and divide it by 1000 cubic meter, because 1 liter is equal to 1000 cubic meter. So divide by 1000 cubic meter in order to proportion our unit. So mean effective pressure now is equal to 64.9251 or 64.93 kilopascal. So since it is in kilojoule, and as we all know that joule is equal to Newton meter. So kilonewton meter over cubic meter cancel the 1m here in the cubic meter, so it would be kilonewton over meter squared, or in short it is kPa. Now let's go for the question number 3. So question number 3, show that the thermal efficiency of the Carnot cycle in terms of the isentropic compression ratio Rk is given by E, or efficiency is equal to 1 minus 1 over Rk raised to k minus 1. So let's go to my solution for number 3. So here I draw here a TS diagram in order for my reference. So here is the solution. As we all know that efficiency is equal to work net over QA. So work net also equals to QA minus QR, and this efficiency can be written also as QA minus QR over QA. So this QA minus QR over QA is also equal to 1 minus QR over QA. Then it is also equal to 1 minus T3 multiplied by delta S, or entropy, over T1 times delta S, or entropy. So the delta S will be cancelled. So it will be 1 minus T3 over T1. So in a relation in our TS diagram, as we all know that from the state 1 to state 2, temperature is constant. So here in our formula of 1 minus T3 over T1, we can know that the relation of T1 is also equal to T2. So would be equal to, efficiency is equal to 1 minus T3 over T2. And the relation of the temperature and the volume is T3 over T2 is equal to V2 over V3 raised to K minus 1. So V3 over V2 is equal to V4 over 1. And the V4 over 1 can also be called as Rk. So we have here the formula for the efficiency now. So 1 minus 1 over V4 over V1 raised to K minus 1. So since V4 over V1 is also equals to Rk, so our efficiency now is E is equal to 1 minus 1 over Rk raised to K minus 1. Now let's proceed to the question number 4. 2.5 pounds of air actuate a cycle composed of the following processes: polytropic compression, state 1 to 2, with N is equal to 1.5, and constant pressure, state 2 to 3, constant volume 3 to 1. The known data are P1 is equal to 20 psia, T1 is equal to 100 degrees Fahrenheit, QR is equal to negative 1682 BTU. So determine the A, T2 and T3, B, the work of the cycle using the PV plane in BTU, and C, the QA or the heat added, and D, the thermal efficiency, and E, the pressure mean. So let's go to my solution. So number 4. So the given in our number 4 are mass is equal to 2.5 pound. State 1 to 2, N is equal to 1.5. State 2 to 3, pressure is constant. state 3 to 1, volume is constant. And P1 is equal to 20 psia and T1 is equal to 100 degrees Fahrenheit, or it is equal to 560 Rankine. Now, QR is equal to negative 1682 BTU. So here we have the PV diagram and TS diagram here. So in PV diagram, from state 1 to state 2, since it is polytropic, PV raised to n is equal to constant. And state 2 to state 3, our pressure here is constant. And state 3 to state 1, our volume is constant. Now for the TS diagram, so here state 1 to state 2 and state 2 to state 3, pressure is constant. State 3 to state 1, volume is constant. Now let's go to our solution. So for the letter A, from the formula of QR is equal to mCV multiplied by the T3 minus T1. Since we are going to find the value of T3 and we have the value of QR, the mass, and also the T1. So as we all know that it is air, so the value of CV for air is equal to 0.1714 pound-foot over pound mass Rankine. It is not BTU, it is pound-foot over pound mass Rankine. So substituting the value of the QR, mass, the CV, and the temperature 1. So using the shift solve in our calculator, we can now find T3. So T3 is equal to 4,485.30 Rankine. And now let's solve for the T2. So T2. So from the formula of T2 over T1 is equal to P2 over P1 raised to n minus 1 over n. So we have the value of our n, the T1, and P1. So let's find first for the value of P2. Since here in our diagram, from the state 2 to state 3, it is said that the pressure is constant. So we can conclude that P2 is equal to P3, since from the state 2 to state 3, pressure is constant. So using the formula of P3 over P1 is equal to T3 over T1. So substituting the value of T3, P1, and T1. So using the shift solve in our calculator, we can find the answer of P3 is equal to 160.1893 psia. So we have now the value of our P3. So let's solve this T2 since we have the value now of our P2. So substituting the value, so using the shift solve in our calculator, T2 would be equal to 1120.50 R or 1120 Rankine. And now let's go to the letter B. So we are finding our work net. So since we know the formula for work net is equal to QA minus QR, and we have the value of our QRs, but we don't have the value of our QA. So let's proceed now. Let's just proceed for the letter C, since we could find here the value of our QA. So for the letter C, QA is equal to Q of state 1 to 2 plus Q of state 2 to 3, which give us the formula of MCN multiplied by T2 minus T1 plus MCP multiplied by T3 minus T2. So let's solve for the value of QA. So mass, we have 2.5 from the given here. Mass is equal to 2.5. Cn, so we don't have the value of Cn, so let's solve for now for the Cn. So Cn is equal to Cv multiplied by K minus N over 1 minus N. So since we have the value of our Cv and our N and our K, since it is air, the properties, one of the properties of the air, which is K. So K is equal to 1.4. So substituting the given value, so Cin now is equal to 0.0342. So we can solve here now for our Q of state 1 to state 2. So mass is equal to 2.5. So mass times Cn times T2 minus T1. So plus MCP of T3 minus T2. So 2.5 also the mass. And as we all know that it is air, so it is already given that Cp is equal to 0.24 since it is air. So substituting the value of Cp here, 0.24 times the value of our temperature 3 and temperature 2. So our QA now is 2066.88 BTU. So now here in letter C, we already solved the QA. So let's go back to the letter B, which is work net is equal to QA minus QR. So now we have the value of our QA. So QR, we also have our value, which is given to us. So substituting the value of QA minus QR, work net is equal to 385.88 BTU. Now let's proceed to letter D. So we are finding for efficiency. So efficiency is equal to work net over QA. Since we already solved the value of our work net and QA, so it is easy for us to solve. So substituting the value of work net and QA, so efficiency now is equal to 0.186. So multiplied by 100 in order to get its percentage. So our efficiency now is 18.60%. So here for the pressure mean. So pressure mean with the formula of work net over volume displacement. So we have the value of our work net, but we don't have the value for our volume displacement. So let's find the volume displacement. So our volume displacement is equal to lower volume minus V1 minus V2. So we don't have the value of our V1 and V2. So we can solve it using the perfect gas law, which is P1 V1 is equal to MR T1 in order to find the value of V1. So substituting all the given values, so V1 now is equal to 25.47 cubic feet. And now let's find the value of V2. So using the formula of T2 over T1 is equal to V1 over V2 raised to n minus 1. So multiplied both sides by 1 over n minus 1 in order to cancel here. So it's equal to T2 is equal T2 over T1 is raised to 1 over n minus 1 is equal to V1 over V2. So substituting the value, so we can find now that V2 is equal to 6.1421 cubic feet. Also, we can use here the perfect gas law, which is no, we can't use the formula of perfect gas law since we don't have the value of our P2. Wait, let me check. So we can't use the perfect gas law in order to find our V2 since we don't have the value of P2. Now we can solve for our pressure mean because we have the value of the V1 and V2. So work net over volume displacement, substituting the value, then our pressure mean is equal to 107.8 87 psia, or pound square inch. So here our answer here is in psia. And now let's go for our final question, our final problem. So number 5. A three-process cycle of an ideal gas for which Cp is equal to 1.064 and Cv is equal to 0.804 kilojoule per kilogram Kelvin is initiated by an isentropic compression state 1 to 2 from 103.4 kilopascal and 27 degrees Celsius to 608.1 kilopascal. A constant volume process in state 1, 3 and a polytropic 3 to 1 with n is equal to 1.2 complete the cycle. Circulation is a steady rate of 0.905 kilogram per second. So compute for QA, work, efficiency, and the pressure mean. So let's go to my solution. So here we have a given here of Cp, Cv, P1, T1, and P2, and N. So from state 1 to state 2, and entropy is constant. State 2 to state 3, volume is constant. State 3 to state 1, it is polytropic is equal to constant. So PV raised to N is equal to constant. So here for our solution, so let's find the value of our QA. So here, let's just find for the value of our T2 since we don't have a value of T2 in our given. So from the formula of T2 over T1 is equal to P2 over P1 raised to K minus 1 over K. Since we don't have the value of K in our given, so let's solve for the K. Since we have our Cp and Cv, we can now solve for K. So Cp over Cp, so substituting value of Cp and Cv, our K now is equal to 1.32. So substituting the value in order to find the T2. So T2 now, so after substituting using the shift solve in our calculator, we can find T2 and the value is 460.9519 Kelvin. So here, let's solve for the value of T3. From the formula of P3 over P1 raised to N minus 1 over N is equal to T3 over T1. Since we don't have the value for our P3, let's just solve for our P3 now. So from the relation of T3 over P3 is equal to P2 over T2, cross multiplying it, so it would be P3 is equal to T3 over 1.3192 kilopascal. So here in our formula here in P3 over P1 raised to N minus 1 over N and is equal to T3 over T1, we can substitute the value of our P3 here in this another formula. So P3 over P1, so T3 over 1,392 kilopascal all over 103.4 kilopascal raised to 1.2 minus 1 over 1.2 is equal to T3 over 300K. So here I tried here for the shift solve in my calculator. So it can't be solved because maybe it is so complicated. So I just solve it manually. So first I solved for the I distributed its raise, which is the 1.2 minus 1 over 1.2. So I distribute it in T3 in 1.3192 over 103.4, and it is equal to T3 over 300K. So transferring the T3 in other side, so T3 is equal to T3 raised to 1/6. Since 0.2 over 1.2, it is, when you divide it, it is equal to 1 over 6. So it is equal to 1.3192 kilopascal over 103.4 kilopascal. raised to 1/6 multiplied by 300. Okay, so we do here in our previous calculation, we just cross multiply it, and now we can solve for the T3. So T3 over 1/6, since the exponent in division, it can be subtracted. So T3 now, it would be T3 raised to 5/6. So copying the previous formula, so 1.3192 over 103.4 kilopascal raised to 1/6 multiplied by 300K. So T3 now is equal to 392.3769 Kelvin. So now we can solve for our QA. So QA, from the formula of QA, is equal to MCN multiplied by T3 minus T1, since we already solved for the value of our T3 and T1, but we don't have the value of our Cn. So let's just solve for our Cn, since we have already know the value of K and the value of N, which is given now. So the formula is Cn is equal to Cv multiplied by K minus N over 1 minus N. So substituting the value. So the value of Cn is equal to negative 0.4824 kilojoule over kilogram Kelvin. So substituting the value. So our QA now is 40.3292 kilojoule per second. And next, let's solve for our work net. So here our work net is QA minus QR. Since we don't have the value of our QR is not given, but we already have the value of our QA. So let's just solve for now for our QR. So here, as you can see, QR is equal to MCV multiplied by T3 minus T2. So we already have the value of our M, our CV, and our T3 and T2. So solving for QR. So substituting all the given values. So QR is equal to 50 kilojoule per second. So now we can solve for our work net, which is QA minus QR, since we already solved the value of our QA and QR. So substituting the value, it would be equal to work net is equal to negative 9.67 or negative 10 kilojoule per second. And now let's solve for the efficiency. So from the formula of efficiency, work net is equal to QA. So we have the value of our work net and QA. So substituting the value, negative 10 kilojoule per second over 40.329. So kilojoule per second. So our value for the efficiency is equal to 0.248, since it should be percentage, so it would be multiplied by 100. So our efficiency now is equal to 24.8%. So next, let's solve for our pressure mean. So our pressure mean, the formula is equal to work net over the V1 minus V2. So V1 minus V2, it is our volume displacement. Since we don't have our V1 and V2 in our given, let's just solve now for our V1 and V2, since it is not given. But okay, next, so using the perfect gas law, which is P1 V1 is equal to MR T1. Since we don't have the value of our R, we should compute first the value of R. which is the formula of Cp minus Cv, since we have the value of these two, the Cp and the Cv. So the value of our R now is 0.26 kilojoule over kilogram Kelvin. So substituting the value here in the formula using the perfect gas law, and now let's using the shift solve in our calculator, we can get the value of V1 is equal to 0.68827 cubic meter per second. And now for the V2, we we use the perfect gas law, which is V2 is equal to mRT2. So substituting the value using the shift solve in our calculator, we can get the value of V2, which is 0.1784. So since we have the value of our V1 and V2, we can now solve for our pressure mean. So pressure mean is equal to work net over V1 minus V2. So 10 kilojoule per second all over the V1 minus V2, 0.687 minus 0.1784 cubic meter per second. And now for our pressure mean, it is equal to 19.8294 kilopascal. And that's all sir, for my solution in quiz 1, the Carnot cycle. Thank you.